Alright, am I live? Looks like that I am live. Hello there, kitties. I'm Carrie. Again. The vacuum tube witch. Again, after Fran. And this time it's gonna be a bunch of things to take apart on my bench. But first let me tell you about a little vintage 80s and 90s stuff meetup today. It was organized in a different place than the last one that took place in twice a year, but looks like there are those little fairs a lot more frequently. Not sure when the next one takes place, but today I went to one. I wore some killer outfit, and it was very small, not like the big one that filled an entire gym, entire hall. This one was held in a restaurant in a shopping mall. And most of the stuff was old 90s and 2000s consoles, like the NES and the old Xbox or PlayStation. Not too much computer stuff. There were some vinyl records and CDs also, and lots of console games, and some talks, some pre-elections. And it was pretty much fun. I met a bunch of people that I knew, a bunch of fellow nerds. Gotta say hello to everyone from both from Fran's channel and elsewhere. Nice to see you again. So I went there hoping to get some parts, but I didn't. And as for old computers, yesterday I got 2 ThinkPads that I'll be working on pretty soon. Let me bring them and show them. Of course, if there was no cocoa on the desk, but there is. So I've got this T61 with the old school logo. This is the 14-inch version, or 15. I'm not exactly sure. Yeah, the 14-inch. Up till now, the only 14-inch laptops that I had was T41 and T43. This is the very old school T61 with this old IBM logo. Paradoxically, here we've got the old IBM logo, but here on the bezel we've got Lenovo already. So this was the weird transitional period laptop from the time when Lenovo took over the ThinkPad line from IBM, but they didn't update all the signage on those laptops because they were end of line already. So if I want to get into this laptop, I will have to detach the keyboard, and only then I will be able to access the RAM. The other laptop is a T400, but this one is far more discombobulated. It has plastic parts of the enclosure damaged, and also it looks pretty unhinged. Definitely not nice, but if possible, I will get the proper replacement parts for it and restore it to its former glory. Yeah, this hinge is completely discombobulated and things look very unhinged right now. The other one should be okay. So I won't use this laptop until I take care of the hinge situation. Yeah, this doesn't look well aligned as well. The proper owner used a nice demo embossed labels on this. Wonder if this one also has it. This is Delta, the other one is Epsilon. Epsilon, not Echo, as in Greek letters. And my normal production laptop, this is a W520. Not yet maxed out when it comes to the RAM. I've got 24 gigabytes of RAM on this thing, and this does the job pretty nicely. I've been using this machine for something like 9 or 10 years. And I will keep saying that the ThinkPad 920 is the last one of the good ThinkPad laptops. Why am I saying this, you might ask? It's because of the keyboard. The 530 and 430 line, it has the new fangled chiclet keyboard. I don't like it at all. And the 520, it's the last ThinkPad series that has the old school keyboards that it just feels great. And then the very familiar keyboard that you know from the 90s already. Of course, all of them, even between different models of the same type of a laptop, they differ because there were two or three original equipment manufacturers for the keyboard, like Alps and Chicony and some other manufacturer. And if you want to swap the keycaps between those keyboards, you will often run into a problem that they are incompatible. If you want to, for example, get a second-hand keyboard with a different keyboard layout and just move all the keycaps from the old one that broke to the new one, you will have to look for the same kind of replacement, and this is best done by removing a keycap from the keyboard, from one of the keys. I think I might need to maybe a better view. Yeah, a close look at the keyboard. So if I just pull it on the upper side, and then it should come off, and then slide it slightly downwards. And there is a clear keycap, and clear key dome with a white scissor mechanism. But other keyboard models, they will have different style mechanisms, and they will be incompatible with the keycaps on this keyboard. Of course, now when I'm working on ThinkPads, showing you this stuff, I take into consideration that there are different generations of ThinkPads, and I will stay in the same one. So now I've got a T520, and if I remove a key, if you take a look here, it's completely different. The scissor mechanism is black and white, the dome is red. So this key won't work on the keyboard that I have in my W520, and vice versa. So that's one thing that you have to watch out for when working on ThinkPads. It's not as easy as you might think, but there's an upside of ThinkPads. They have excellent documentation, and it's still around. The old service documentation from IBM and Lenovo. I call it the ThinkPad Bible, because that's just a whole service manual for the entire line, for the entire generation of ThinkPads. And they describe the disassembly and assembly in good detail. They have come in handy so many times that I can't recall anymore. And of course, now that I have been having different ThinkPads for 12 years now, or 11 or 12 years, I can just take one apart and remember how to put it back together with no service manual. unless we're talking about some rare cases when you have to take it apart even further than usual. But yeah. Sometimes I had to fix a hardware problem by taking the W520 all apart down to taking the motherboard out and cleaning it with isopropyl alcohol. Because I spilled some liquid on the keyboard and it caused short circuit in electronics, and most of the time this would be a laptop killer, but not for ThinkPad. Those things are reliable, and I fully endorse them. And tell you what, a fun fact that NASA has been using ThinkPads on the International Space Station for years. And they also moved to using Debian GNU/Linux instead of Windows. Pretty much like me. So Keritech is pretty much like NASA on the ISS. All ThinkPads and all Debian. So they go back to the table. And I will show you the oldest ThinkPad that I have in my lab. Let's get a better view on this thing because it's so magnificent. So this is the ThinkPad 380ED from the 90s, 97. The year Fallout was released. Unfortunately, I will have to put a lot of work in getting this to run the way I want to run, because I'd like to install a decent size hard disk. This one originally had something like 1.2 gigabytes of HDD. I want to max it out at 6 gigabytes, but I will have to get a HDD that actually wants to work with the BIOS. Otherwise, it's not detected and it doesn't work at all. So this is marked type 2635 or 263S. And this one has an old style power supply that's been around since the 90s. And the T43 still used the 16 volt power supply. So here is the model number 380ED. And the keyboard layout, the original one, was German. It's from Deutschland! Wonder if I can just lift the key. The scissor mechanism is a lot different from what I showed you with the 520 generation. It's a lot more symmetrical. As a matter of fact, this is the first time ever I'm taking a close look at the keyboard, what lies beneath. So I guess that now that I have seen the scissor mechanism, the way to install the keycap on this keyboard is just by laying it flat on the mechanism and pushing downwards. And I learned a new thing today. I wonder if I can get a power supply and try to run it. The old school IBM power supply, 16 volts. Of course I had to repair the plug, but this is the old school ThinkPad PSU. Coco, would you please, for crying out loud, not do that anymore? And there's the power port on the back, next to a PS/2 port for the mouse. There's a serial port, the RS-232, the parallel port, and also the display VGA output. This thing has no USB, not at all. It was just, it was not just not done in the first place. USB only got traction in late 1990s with Windows 98. I'll try to hook it up to the mains, and I need the trefoil cable. So the power switch is on the side. Wonder if it will have any effect. Fire to the wire. The LEDs are coming up. There's some image on the screen. And the slider next to the screen, this is a contrast slider. Looks pretty washed out. There's a Windows 98 install CD in the drive. A German one. Ja, Deutschland! But because the laptop either has the HDD taken out or the incompatible HDD, it doesn't come up. So I will need the 6 GB IDE 2.5 inch HDD so that I can not just install the operating system on this thing, but also install some of my favorite games, like the Fallout 1 and 2 or Half-Life. I wonder if Half-Life is gonna run on this thing at all. With its integrated graphics, I don't think it will be up for the job. But yeah, I will try to run Half-Life 1 on it. I don't have to try to run Doom on it because I'm sure it will run Doom, but Half-Life is a different story. And the Half-Life series are one of my favorite video game series ever, together with Portal. And of course, when talking about different games than FPS, than Command and Conquer series, the old Command and Conquer games from Westwood Studios, that really takes the cake. Like up till Red Alert 2 and Yuri's Revenge, all Command and Conquer games, maybe save for Renegade. I haven't played that one, but that's not a real-time strategy. It's an FPS. And I could talk a lot about computer role-playing games. There are lots of titles I've played and loved. Right now, we are doing a collective playthrough in my relationship of Witcher 1. I never played Witcher up till now. And we are gonna do the entire series from 1 to 3 and the Blood and Wine expansion. So I think I will drop a Witcher reference from here to there. And now I'll just read the chat. There's not much stuff going on. Hey Rachel, nice to see you. And yeah, the skirt is nice, but today I wore a whole a way better outfit when I went to the vintage computer meetup. I wore a leather little black dress, a leather bolero, some long leather gloves and high heel boots. and I bought to accessorize this. And yeah, I felt so confident. And why did I do it? It's because a few weeks ago I started doing some cleanup and looking through my clothes and trying them on to see if they still fit, because through my transition from my HRT I gained quite some weight, and it turned out that a lot of my old clothes, especially pants, didn't fit anymore. So I decided to check them all, and I will be selling a lot of stuff off. But this also kinda also kinda reawakened my interest in alternative fashions that I had. And I had it a bunch of years, over a decade before I even started transitioning. I was into alternative slash gothic fashions since 2005. And yes, as time went by, I toned it down a bit, but yeah, nothing too outrageous. But I think that I will be getting back to dressing up somewhere, doing something crazy, and not giving a shit about what people around say and think. Time for the old Kerry to come back. And now I'd love to get myself a corset to wear every day. Yeah, I talked about corsets every now and then, and also talked about how I found Fran in the first place. Yeah, hi Memsis. The old times. Like, back when Bill Gates said that no one would ever need more than 640 kilobytes of RAM. And now you have 640 gigabytes of RAM in servers. Maybe even more. Who knows? Gaming setups, they go. I think that the high-end ones sometimes go into the hundreds of gigabytes of RAM already. 64 is pretty standard. 32 would be a little bit on the low side for a gaming rig. Of course, it's perfectly doable, but yeah. The other thing is that with modern computers, when it comes to gaming, most of the power it's in a graphics card, like RTX 3090 or even more modern models. Most of the workload that games put on the computers, it's graphics processing, and the CPU is not all that important, not as important as it was in the 90s, but still, the better, the higher spec, the better, and it's especially important if you have lots of concurrent jobs running on the computer. Yeah, thinking about upgrading to 32. Could be a good idea. My main computer over there, the Stream engine, not Steam engine, it's 16 gigabytes. It's right here. Stream engine. And below that, yeah. Keritech Electronics main computer. So this is an industrial PC enclosure that I got in something like 12 years ago. Here we've got a big fan under the cover. Here I've got a CNC milled cover plate for a memory card reader. And yeah. Oh no, it's not CNC milled. I actually cut it from some foam-ish material with a knife. This was CNC milled from die bond. This is a fan that cools the HDDs. This machine has 2 HDDs, and there are USB and audio ports, and there's an optical drive that hasn't been in use for a long time and doesn't really want to put the drawer out. Not unless I help it with a needle. Maybe it's too short. I don't really have so much use for an optical drive on the main computer. It's there just in case. The lava lamp is combobulated. There's no brain freeze. So we're close to the end of hour 1. That would be about the old ThinkPads that I have. And I also have a box full of discombobulated ThinkPads and spare parts. That weighs something like 20 kilos or even more. And I don't necessarily have all the parts for all the models I have, but when I need to fix or Frankenstein some good ThinkPad out of several non-working ones, then it comes in handy. Yeah, rack mount cabinet. This is this good stuff, and I have a rack, a small 16U or something like that rack that this main computer stands on. So what's in the rack? This is my audio gear. Now I'll get the guitar out. The acoustic one. Get it back there. In the electric one. Get it here. And what's in the rack? Then the top piece, this is the WS1 vacuum tube amplifier that I built 11 years ago with a pair of EL84s per channel. Right below that this is a preamp, a phono preamp, also built in 2020, I think. The next one is a mixer. Crap, I need more light in this place. Yeah, hope it helps. The mixer with 2 microphone inputs and 8 stereo balanced line inputs. And that's almost all devices that I built. Right below that there's a Diora CD-0421 CD player, the Diora MDS 440 tape deck, the ZRK T-7010 tuner, and the Keritech AC1 audio computer. Looks like I will have to recombobulate the software on the AC1, because it used to work, but now when I press the big red button, try to turn the audio gear on, it doesn't seem to work. I think it's some services just stopped working after a operating system upgrade on this thing, so I'll just have to SSH into this thing and get some things right. But other than that, it's not a physical damage. A glimpse on the bench. We'll be getting to this real soon. I'm using an old microphone stand for the Keritech Pro camera. It's very handy and a lot better than photo tripods because with a photo tripod you couldn't get the camera close to the object. With this one I can have some very close-up shots of what I'm doing at the bench. Yeah, that's some cool gear, indeed. And yeah, let's just eat a muffin because I made some coconut muffins yesterday. Cute little muffin. This joint has gone shut. So, hour 2, and what do we have here? Got a bunch of little stuff that has been kicking around my lab. And I will be doing some teardowns of the items that I have here. First one would be a smart-ish light bulb. Aglow Crosslink-Z LED warm white that uses the Zigbee protocol that's pretty popular in home automation. And I wonder if I could get this thing to work with Home Assistant with a Zigbee interface or adapter or bridge. Look at the shape of the bulb. Looks pretty much like in the first 3 decades of the 20th century. Loveliness, very stylish, and of course we've got 4 linear LED elements. And if we take a closer look, there is some electronics in the base. If I wanted to take it apart, then I would have to destroy the entire light bulb. I don't want to do that. I think I will only do that if it breaks down. Because I only have one. I'd like to enjoy it. But this thing came with a remote control. And I think that I might be taking the remote control apart to see what's inside. There's also your instruction sheet. Yeah, like how to install it and how to control it. I wonder if I can get it to run on the bench. So I've got this lamp holder and a cable for testing light bulbs. It also has a power switch. Turns on. Nice and shiny. And of course it's flickering. Naked eye can't see this, but if you look at the light patterns, it has a very significant stroboscopic effect. At 1080p, 30 FPS, I think, or it's clearly visible. Wonder if changing the camera will change anything. Yeah. Okay, so let's try the remote control. Battery's in, so it should work. And it works. I think that changing the brightness really works. This is the Mad Max. Pretty orange. Warm white, low color temperature. Whenever I press the key, the LED lights up as a feedback. Favorite presets. Yeah, this cycles the brightness so that the bulb looks like it's flickering. And this will change the color temperature for the lights that support this. Did I break it? Yeah, if I go back to the favorite setting, it has some steady light, but if I press one of those buttons, it starts flickering like mad. So that would be for the light bulb. And let's try to discombobulate the remote control. So I need to unlatch this thing. So it's apart. There are battery springs on the board. A sticker here. A Bluetooth module or a Zigbee module. And on the other side, some nice switches on the keyboard. It's not the cheapest rubber dome stuff. There's a rubber that presses against those switches, but it's not the cheapest crap around. Come on, focus. So those studs press against the dome switches, and there's a nice tactile click when you press one. Good design. Putting it together is easy peasy lemon squeezy. You just start from the narrow side. But you have to watch out for the battery contacts. All of those buttons give a nice audible click. And of course, let's test it. And it works nicely. I'll be doing some more tests on this light bulb if I get a bridge and experiment on integrating this with home automation, because that might be an interesting project. I'm deploying Home Assistant in the lab. I got it installed on a Raspberry Pi 4. And another integration with the Home Assistant that would be a Xiaomi robot vacuum cleaner. But this is a completely different story. Now that I still got this light bulb, I think I can use it for testing some other devices, because I've got 3 of the remote control sockets. They look quite bulky. And there's also a handheld remote for them. Every channel has separate on and off switches. And this system has been factory configured. So I can just plug it into a socket on my bench. So there's the equipment under test socket. There's my lamp holder. The switch is turned on. And there's the remote control socket and the remote control. It doesn't work because there's no battery in it, but I ordered 2 of them. comes in nicely. So that's the socket number 1, right? You can hear the relay click. I can even daisy chain those. Turning 1 on. It's not enough because I will have to turn 2 on as well. Yeah, same for number 3. And I just broke the rule, the Dave Jones rule. Don't turn it on, take it apart. This one also has a rubber insert, but that's not rubber, that's plastic. And the plastic buttons press against tagged switches. And commencing discombobulation. This is an interesting part. It's marked SAW on the silkscreen layer. So, it's NYR43A. And for 33, that suggests the frequency 433 megahertz. Oh my goodness, this looks bad. Looks like some water damage or something. But the device is still functional. There's some nasty solder blobs. Low quality job, if you ask me. And those jumpers on the PCB, I guess that they are here for setting the exact frequency the device works on. And the integrated circuits marking is HS2260A. Nothing I'm familiar with. This tagged switch has been soldered only on one side. See how it rises up. It's not soldered on this side at all. There's a pad, but it's not filled. Might be pretty nice engineering here, but the build quality, it's just complete rubbish. I will also take one of the sockets, the controllers apart to see what's happening inside. So this has a quality control sticker over a screw. Void the warranty. And I need to use a double claw screwdriver to get down to it, but I have the right tool in the lab. This comes in handy a lot of times. So where's the proper tool? This would be this one. Maybe I can even go down a size. And now I can just turn those pesky little buggers. Not caring about the manufacturer, not wanting anyone to get into those devices. Alright, no hidden stuff. And this comes apart. The grounding contact that goes right through the plug, and this is a Unishuko type plug with side contacts for the Shuko and the round contact for the CE7/5, the French type socket that's also used in Poland and Czech Republic and Slovakia and a bunch of other countries. We didn't adopt Shuko. Russians did. Pretty interesting that Russians adopted Shuko. But Poland adopted the French system. So we've got 2 screws, and the printed circuit board comes off. It has a relay, something that looks like a thermal fuse that's supposed to hold up to 102 degrees Celsius. AFE, the relay is specified at 12 amps, 250 volts AC. There's a capacitive dropper for powering this thing up. The HS2272C integrated circuit, this one is actually a DIP one rather than SMD. A separate board with high frequency filters. It has a coil and a adjustable coil with a brass slug and a electrolytic capacitor. On the other side we've got a full bridge rectifier. And yeah, this looks like a Zener diode, some surface mount resistors, capacitors and transistors, maybe a voltage regulator IC. And that would be pretty much about it. The connections on the live side are made as short as possible. I'm not sure if those wires are made of copper. Might be copper-coated steel. No, it doesn't stick. I guess it's copper then. The neutral on the left. This shouldn't be done like this in Poland. By convention, not by any strictly enforced regulations, but by convention here in Poland, we've got a live conductor on the left side of the ground contact, and the neutral is on the right side, and here it's reversed. So if I used it in Poland, it would switch the neutral wire instead of the live wire. Definitely not the good thing, and it's also good that I checked this. I won't be reverse engineering it, but yeah. Knowledge gained, lessons learned. Time to put it back together. Come on, screw. So that's for this. Now let's take a look at this multi-switch WS909. This is a multi-channel antenna amplifier that is used in residential settings in blocks of flats for amplifying the TV antenna signal going to the flats. Typically we've got as many of them as we have flats in a staircase, or if a box with signal amplifiers has several staircases in it, then it will just have a few of those units combined. So this has 9 inputs plus plus the terrestrial signal, and 9 outputs plus the terrestrial signal. Every channel has a gain adjustment. It also feeds the DC power out to the signal source like an antenna. So signal comes out, but power comes in on this side, and power goes out on the signal input side here. The terrestrial signal has a switch. I don't fully understand what's it. Active or passive? And after I took those holders off, I can lift the covers. Got a PCB with several channels. They are identical. And I could reverse engineer one of those, but I won't be doing it now. This is very much the IMSI guy kind of stuff. All built with surface mount components. Another thing that's the printed circuit board is soldered into the metal shielding box. It's soldered on the top and on the bottom with spot soldering on the sides. And also the shielding walls are soldered to the box on both sides and also to the printed circuit board. So there's no easy way of taking this assembly apart and getting into the channel if you want to replace one of those pesky little surface mount buggers. This is gonna be a hard task. So definitely not built for surfacing, and there's a pair of through-hole inductors. The inductors are thicker than resistors. The, shall we say, aspect ratio of an inductor is different. It's lot thicker than a comparable length resistor. That's how you tell them apart. And there's the switch and a bunch of active components. Like a transistor or something like that. So, back together and off it goes. And time for another device. The big one. Potentially rack mount. IT people already know what it is. This is a old school KVM switch. Keyboard, video and mouse. That works with VGA analog video connectors and the old school PS/2 keyboard and mouse connectors. It has eight computer connections for getting the controls out of different machines. And the console connection, here you connect the monitor and your keyboard and a mouse. Here you connect the cables to the computers. And there's the power. But you might... this was made by Compaq, by the way. You might ask, how is the switching done? And the answer is the serial port. I don't know the exact protocol, what data to send it to switch to a particular machine, but it might be as easy as just sending a machine number, input number. So, what's inside, you might ask? Oh, there's one more. Warranty void, of course. I have become Kerry, the voider of warranties. Slides off just like this. And look at that. A huge ass printed circuit board full of surface mount components. All connected with the sockets. I won't be taking the board out of this device. Look underneath the circuit board. It doesn't seem that there are any components there. Here we've got the Xilinx Spartan FPGA field programmable gate array. 8090S 8515 microcontroller. Some other Xilinx, probably also FPGA, but I'm not sure of that. Might be some memory chip. Another microcontroller. '74 HCT 4051. And lots of transistors and resistors and capacitors for each channel. And of course the power supply connector. The power supply, it's +5, +12 and -5. Of course it's a switch mode power supply. What else would you expect? The capacitors look good. They used Nippon Chemicon, good brand. looks like nothing is burnt. There might even be a voltage adjustment right here. And there's a nice ground connection on the enclosure. It's riveted, it's a riveted threaded stud. Probably the best way of doing a ground connection. Ensures that the contact is tight and safe. Still 20 more minutes, and still a few devices to take apart. But I'll just have a drink and read the chat. Yeah, that was a lot of ripple on the low power setting. I'm sure that the LED had a PWM control, so it only lets the current part of the time rather than controlling the voltage. Yeah, full bird rectifier. Yeah, a lot of work on making the mold. Come on, focus! What's a TV signal? The VHF or UHF signal for the TV antennas. So I guess that's about it for the chat. It's very calm here. Almost nothing is happening. So back to the bench. Yeah, got some notes. So what do I have here now? What am I taking apart? It's a very classic Pico FZ1, not the Gibson Maestro FZ1, because that's a completely different FZ1. But this can give you a different kind of satisfaction if you're into the classic model railroading. And this was about the best power supply you could get in the 80s or 70s. And of course I will. I got it from my local hackerspace. And time to get into this thing. Has a knob with a slotted ring nut. And slotted screws on the other side. Ready to accept a big flathead screwdriver. I got this unit from my local hackerspace and it has been abused. There are burn marks from soldering all over the enclosure, but this is pretty big and heavy, but rated only at 33 volt amperes. And the power output is 1.7 up to 12 volts at 1.2 amps for the track power that can go positive or negative, plus accessory power AC 16 volts, 1.2 amps. Nice old school M4 screws. This one's not completely undone yet. And M3 thumb nuts for connecting the wires. All metal binding posts. So let's lift the cover. And this reveals a transformer. It's very big for a transformer of this puny 33 volt amps power. The core cross section would suggest something about 100 volt amperes or even more. There's a selenium 4-bit rectifier. And there's a pretty complicated switching setup for the polarities changeover. In the central position it's cut off, but let's have a look at the sliding tab on the transformer. It's somewhere there, way down inside. I just couldn't resist. It's hidden in the shadows. I shall bring out the light. Hidden in the shadows. I shall enlighten you. So now you can see the tab moving on the winding. In fact, there are two tabs, both of them on each part of, on each column, on each winding of the transformer. There's not just one, but two of them. And a part of the winding section is used for accessory power that goes to the super pair of sockets. And this is fixed. This is not adjustable. And this is IC. There's your thermal fuse. A self-resetting thermal fuse, both for the track and for the accessory power, with teeny tiny bulbs. Look how cute they are, teeny tiny. That light up when there's an overload or short circuit condition that makes the thermal switch disconnect. They just sit in place, tighter than ever Granger's laces, but I think I managed to get one of them out. Look how cute it is. Like a little kitten. Teeny tiny. Like 5 millimeters diameter here. You know what? I got a vernier caliper for that. Five millimeters. Looks like it's rated at 9 volts. And now I need to put it back in. Which may be harder than I thought. It's going. Yeah, might be all the way in. So if you take a closer look way down inside, then you will see those contacts changing over between the pairs of studs. Then the pairs of studs here while the central two moving contacts swap the polarity on the output, and they swap the polarity between the forward rectifier and the output. And the side contacts go to the AC side of the forward rectifier. Then the thermal disconnect is on the AC rather than DC side. And I guess that they switch over, deciding the phase of the winding of the transformer. Pretty clever. It's built with metal and phenolic. Old quality stuff. Very reliable and almost indestructible. They don't make them this way. And if you take a closer look, you can even find the Pico and FZ1 logos on the metal bracket stamped in the metal. Attention to detail. Attention to detail for the win. And those red caps, they are just covers for the indicator lamps. And when one of them lights up, then it's an overload condition indication. Both for the accessory power and for the track power. One of the screws was missing. And of course it has metal inserts. They are not molded in. They might actually be the standard hex nuts in the sockets with plugs on the other side. That's how they used to do it back in the day. Back in the German Democratic Republic in the 70s and 80s. So that's my FZ1. You might ask, Carrie, but can a FZ1 power an FZ1, the Gibson Maestro one? I'm sure it could. Just don't do anything stupid, okay? Now it's almost time to go, but I'm not going. I'm just getting naughty. I'm getting slightly naughty. Yeah, a cheap magic wand counterpart. It's working, and it's powered from the mains. Has an adjustment knob. So what's inside? Of course I was gonna take it apart. What else would you ask? I just need a thinner screwdriver. And taking it apart, we've got 2 wires going to the motor. Then the motor is in the head, so I think I will also take this one apart. There's a motor with a half circle vibrator that you might know from mobile phones. This is probably a low voltage motor. So let's put the head back together. I never took this one apart, by the way. Let's take a look at the electronics in this thing. Then the mains wire, its only strain relief is this rubber block. Fortunately, it doesn't slip against it, and it comes in to a surface mount full bridge rectifier and fuse. The fuse is soldered on this side, but not on the other. Of course, the filter cap. Some SO8 integrated circuit for the converter and a transformer. On the output side, goes to a surface mount diode. So this would be a low voltage motor with a switch mode power supply with the transformer, but the way it's made, it's just so sloppy and with no consideration for any safety precautions. No no air gap in the printed circuit board. And there are traces going to the AC side. This is the switch that's mechanically coupled with the potentiometer. Oh, or the pot itself goes to the control circuits on the primer side. And now I'm like, what? Definitely a very sloppy way to do electronics, especially with when we're talking about devices that come into contact with human body. And sometimes they get moisture, and I would definitely not want the motor or any other part of the magic wand to come into contact with moisture when it's on the 230 volts mains potential. So, as Diode Gone Wild would call it, super dodgy! Definitely not the thing I would trust in the bed. But still, taking it apart was pretty interesting. Maybe I should open a second channel. Carrie's Naughty Teardowns. But I don't have enough stuff for that. Maybe you should send me some stuff. Very many. Yeah. So, back to the desk. And let's read the chat. Yeah, volt ampere is not exactly the same thing as watt. Volt ampere is an apparent power of alternating current, but there's also a thing named power factor that comes into play here. It's not always 1. It is 1 for resistive loads. On a resistive load, the apparent power is the same as the real power in watts. There's also reactive power in VARs, and on resistive load, it's 0. But if we have capacitive or inductive reactive load, or a load that has a capacitive or inductive component, like a motor or a fluorescent lamp or a switch mode power supply, then reactive power comes into play. It causes losses in the electrical grid, and that's it should be avoided, but it contributes nothing to the effect of how the device works. like it doesn't provide any useful work in the motor. It just drags the mains down, and this reactive power also causes the harmonic distortion of the AC voltage. It degrades the waveform. So any larger uncompensated load should be avoided, and in industrial settings where you had lots and lots of electric motors, this was done by adding a capacitor battery with variable capacitance. This was done by switching the capacitors according to the inductive load, so that capacitance compensates the influence of inductance on the grid, pulling the power factor closer to 1. Okay, what's next? Yeah, Gary Ramsay got it right. That's something about the circuit theory and alternating current. It's not as simple as direct current. There are some factors that come into play, and that also involves some complex maths. And by complex maths, I mean complex numbers, the real part and the imaginary part. And of course some other algebra, like matrices, stuff like that. Stuff I didn't get when I was studying electrical engineering at the university. I stayed there for 1 semester and then moved on to studying chemistry. Yeah, it's a low voltage motor, as it turned out. But if you don't have proper separation between the high voltage and low voltage side, then it's not gonna be safe. And Daniel Danek, aka Diode Gone Wild, has done so many teardowns of cheap phone chargers, taking it literally apart down to the transformer core, like taking the switch mode power supply's transformer all apart, unwinding every single winding and undoing the insulation layers. He is very thorough in his teardowns. While I usually take stuff apart to see what's inside, but stop at the point when I could damage it irreversibly. Most of the time, the one that I did a week ago with that liquid soap pump, it was a destructive discombobulation, but the turndowns I did now, they were all non-destructive. But Daniel goes all the way. Discombobulates the devices into destruction. and analyzes what's inside with great care, and he just looks at every single teeny tiny detail of the device's construction. He has a lot of knowledge. He's a good engineer. Yeah, it's probably made in China. I'm pretty sure that the soldering quality in this thing, it also leaves a lot to be desired, with nasty solder blobs on the through-hole side, with grayish look that suggests that their cold joints are made of very crappy quality solder. As a matter of fact, I even saw the solder that has 60% of lead and 40% of tin. Normally it's the reverse, 60% of tin and 40% of lead. But I saw that 60% lead solder at our local hackerspace. No! Made in fucking China. The crappiest crap that I ever touched. I tried to solder with it. Failed. You know what? I will show you the good solder. Got myself a few spools of this Brocadas, 63% tin and 37% lead. This is the eutactic solder that both metals will both melt and solidify in the exact same temperature. And this yields nice and shiny and strong joints. I still need to do a side-by-side comparison soldering project between the 6040 and the stuff that I used to use, and 6337, the stuff that I use now. Just to look at the differences. I've got a perfect kit for that. A hourglass kit that Imzai guy once made a video about. Like, I even got it here in the lab. Lots of LEDs, and I plan to do one half of the hourglass with 6040 and the other half with 6337. I will probably do the surface mount stuff with 6337, but I would do the LEDs first and foremost, with two kinds of solder. Yeah, quality lead-free, but lead-free has a slew of other problems, like like the temperature, and it's a lot more brittle this way. By the way, and there's this 97% lead-free solder, SN97 AG3, and this solder, it's pretty popular nowadays. And this was the stuff that was used in the old vacuum tube Tektronix oscilloscopes for soldering on the ceramic terminal strips. So now, if you have a vintage tech scope, you can fix it with the typical the typical lead-free solder that contains silver. That's pretty nice. Okay, so that would be for this week's stream. It's 22 hours 22. Maybe 21 now, but it's gonna turn 22 in about a moment. It's 9.36 degrees Celsius outside. 2183 in the lab. And I'm a teeny bit tired, thirsty and hungry, so I will just call it an evening. And without further ado, stay determined and carry on.